models that have good performance by performance. But today we actually want to understand how are these models being able to carry out the decisions that they are taking. Like, why are they doing this? Yes. So, and this is carried out in Explainable AI. Well, Explainable AI is okay, it helps to provide clear understanding, like clear, understandable explanation of why a decision is being made or an action is actually being carried out. And for our project, we chose to use 3 techniques. That's visualization, knowledge graphs, and LIME for attention weights. Yes. And personally, I'm going to take you through the visualization bit, and my groupmate, Twice Eugene, is going to take you through the other 2 parts. That's knowledge graphs and the LIME for attention weights. Yeah. So we're going to start off with the visualization. Yes. So on our first slide, we're talking about the 3 that we actually use. That is visualization, as I've said, knowledge graphs, and the LIME for attention weights. And we want to first understand what is attention. Well, attention mechanisms allow models to focus on relevant parts of input data while making predictions. So a question that will be given will be long. Like maybe what is this and that and that and that. But the model that is supposed to give you a response is supposed to have a focus on particular points. Like, okay, I'm going to focus on this word and this word, and these are the words that will be relevant to predict the outcome. So, and all this is based on attention and all that. So in attention, we use something called attention weights. Attention weights are maybe you find the other one weighs 0.1 and the other one weighs 0.5. So in that way, when you get to where you know, okay, this one is more important than the other. So that's when you find that. So they based on attention weights to carry out a decision that is going to be made. So on this next slide, on slide 2, we are going to talk about visualization in particular. So visualization, attention in transformers. Well, we know that a transformer is a deep learning model that uses self-attention so that it could understand the relationships of the words. Okay, the relationship between the words in a sentence. And this actually goes on in 2 ways, I can say. The first thing that happens is there are going to be transformers and attention. And then after the transformers and attention bit, they are going to visualize this attention that we have actually found out. So the first thing that happens is they get the sentence. Let me say you've given it a whole sentence, and telling it maybe what's this when this is given. It's going to get each word and it's going to break. Okay, it's going to get the sentence, and each word is going to be transformed into a vector. So after each word being transformed into a vector, after each word is transformed into a vector, they attach attentions to each. The attention scores are calculated, and they based on the query, the key, and the values, as a particular formula is always provided. Yeah. And then after basing on that and the query, the key, they have a formula that they use. They calculate the attention score. So when we get the attention score, we visualize it, and this one can be put in like a heat map or something like, oh yeah, it's actually a heat map, so that you can tell that, okay, on this map, this word and this one are more important than the other. So on the next slide, we actually show, for example, an example of a question that shows maybe what is let's move. On this question here, they're telling us a teacher has 10 apples. He gives 3 to one student and 2 to another. How many apples how many apples are left? So when you look at this, it tries to show it gives attention weights over maybe this is more important and this varies with this varies. So the model is going to base on these attention weights to get a decision. So it helps us understand how it's carrying it out. So it carries out its decision, it's going to base on attention weights. And the importance, lastly, I'm going to talk about the importance of visualization, the technique that we actually shows. On the next slide, it tells us that it helps to explain, it's explainability in NLP. That's why it can be applied. So it helps us to interpret the learning models, and then it also provides insight of how the model is actually making the decisions. It helps us to summarize text, like it gives focus on this and that, and then it also helps in machine translation. Yes. Thank you so much. That's all I had.
Good evening. My name is Eugene Twice, and I'm going to be taking you through knowledge graph representation. In our case, we are dealing with solving math word problems, so knowledge graph representation of math concepts. So a knowledge graph basically is a graph structure where the nodes represent entities, or in our case, the math concepts, and the edges represent relationships. So this allows visualizing complex networks of knowledge and their interconnections. So when we have nodes, they're going to be representing the mathematical objects like algebraic equations or maybe geometric shapes. Then the edges represent the relationships between each of those concepts. So for example, each edge may mean maybe it's a part of this or leads to this or depends on this. So an example, if we are working with elementary mathematics, we are seeing that we have subtraction, addition, and algebra. So we can see that they are all interconnected in fractions, for example. So these are our concepts. We look at the concepts of addition, subtraction, algebra, and maybe fractions. Then these nodes represent how they relate to each other. We can do algebra with regards to fractions. We can do subtraction of fractions or even addition of fractions. Then their importance is number one, we can show that the concepts in the mathematics are very interconnected. So when we want to help the model to understand these relationships, we can help when the model is trying to teach the user. It's going to help the user to know that one concept is going to aid in learning the others. Then the educational pathways are based on the interconnections. Then it's going to help systems provide a personalized learning mechanism. But we are going to also talk about table model as interpret input data and observing how each of these predictions keep changing. So when we want to visualize attention weights in a model, it will help us to explain why the model attends to particular parts of the input. So, for example, maybe certain words in a sentence. So, for example, if we have a question, like we say a teacher has 10 apples, he gives 3 to one student and 2 to another. How many apples are left? Does the teacher remain with? It will look at the words, not the numbers, and determine how important each of these words are. So in this case, the words, for example, how and student and left are more important than the word apples. So you can find the apples have a negative importance score, and it's not going to get about that. Yes, that is it. Thank you.